In this video, we will together learn how to determine the trigonometric values of any angle, and thereby master the trigonometric values of angles in the first quadrant. First, let's understand the coordinate system. The coordinate system consists of the horizontal x-axis and the vertical y-axis. These two axes intersect at the origin O. In this coordinate system, we draw a circle. Its radius is 1 unit, so we call it the unit circle. This unit circle intersects the coordinate system at 4 points, respectively. Point A, with coordinates 1, 0. Point B, with coordinates 0, 1. Point A prime, with coordinates -1, 0. And finally, point B prime, with coordinates 0, -1. Point A is referred to as the starting point. Conventional rule: choose the direction counterclockwise as positive. As a dot moves along the circumference of a circle in the positive direction, the line connecting the center O and the dot will rotate around O, creating the trigonometric angle alpha. Now this angle alpha takes on a positive value as the dot moves positively. If the dot moves in the opposite direction, then angle alpha is negative. After the dot moves and creates an angle alpha, projecting perpendicularly onto the horizontal axis to find its horizontal coordinate. Let's assume the horizontal coordinate of the dot is A. Then, A is the value of cosine of alpha. Projecting perpendicularly onto the vertical axis to find its vertical coordinate. If the vertical coordinate of the dot is B, then B is the value of sine of alpha. Here, the angle of rotation is alpha. The horizontal coordinate A, the vertical coordinate B. With this notation, we conclude that cosine of alpha is equal to A. Sine of alpha is equal to B. Therefore, finding the trigonometric values of sine and cosine is equivalent to finding the coordinates of the dot. We establish this notation here and encapsulate it. We proceed to find the trigonometric values for commonly encountered angles. On the x-axis, we add coordinates with special values. The square root of 1 divided by 2. The square root of 2 divided by 2. And the square root of 3 divided by 2. And we do the same for the y-axis. Initially, the dot is located at the starting point A without any movement. Hence, its rotation angle is 0. And its coordinates coincide with point A, so its coordinates are 1, 0. Instead of writing 1, 0, we can express it as equivalent to the square root of 4 divided by 2, the square root of 0 divided by 2. Let the dot start from the point A, moving in the positive direction. The rotation angle is now pi divided by 6. Projecting perpendicularly onto the horizontal axis, find the horizontal coordinate of the dot. Obtaining the value, the square root of 3 divided by 2. This is also the value of cosine of pi over 6. Projecting perpendicularly onto the vertical axis, find the vertical coordinate of the dot. Obtaining the value, the square root of 1 divided by 2. This is also the value of sine of pi over 6. Thus, the rotation angle here is pi over 6. The cosine value of pi over 6 is the square root of 3 divided by 2. And the sine value of pi over 6 is the square root of 1 divided by 2. Bringing the dot back to point A, continuing its movement in the positive direction. The rotation angle is now pi over 4. Projecting perpendicularly onto the horizontal axis. The value of cosine, which is square root of 2 divided by 2. Projecting perpendicularly onto the vertical axis. The value of sine, which is square root of 2 divided by 2. Therefore, with a rotation angle of pi over 4, the cosine value of pi over 4 is the square root of 2 divided by 2. The sine value of pi over 4 is the square root of 2 divided by 2. Similarly, the dot continues its movement in the positive direction. The rotation angle is now pi over 3. The horizontal coordinate obtained is the square root of 1 divided by 2. The vertical coordinate obtained is the square root of 3 divided by 2. Thus, with a rotation angle of pi over 3, the cosine value of pi over 3 is the square root of 1 divided by 2. The sine value of pi over 3 is the square root of 3 divided by 2. And finally, we move the dot to the largest angle in the first quadrant of the circle. That is pi over 2. When the rotation angle is pi over 2, the dot has coordinates coinciding with the coordinates of point B, meaning its coordinates are 0, 1. We transform the coordinates 0, 1 becomes square root of 0 divided by 2, square root of 4 divided by 2. In summary, as the value of alpha increases in the first quadrant, from 0 to pi over 6, pi over 4, pi over 3, pi over 2, the value of cosine alpha decreases according to an easy-to-remember rule. The square root of 4 divided by 2. The square root of 3 divided by 2. The square root of 2 divided by 2. The square root of 1 divided by 2. The square root of 0 divided by 2. On the other hand, the value of sine alpha increases according to a similar rule. The square root of 0 divided by 2. The square root of 1 divided by 2. The square root of 2 divided by 2. The square root of 3 divided by 2. The square root of 4 divided by 2. The variation of sine and cosine values as alpha increases in the first quadrant is as follows. The following effect is programmed using the Python language by Nguyen Tin Academy. Thus, as alpha increases, the cosine value decreases while the sine value increases. Now, let's decrease alpha from pi over 2 to 0. As alpha decreases, the cosine value increases while the sine value decreases. The following is a way to master the trigonometric values. These are the trigonometric angles and functions to be found in the first quadrant. First, we need to fill in the values for pi over 4. The angle pi over 4 has equal values of sine and cosine, both equal to the square root of 2 divided by 2. We fill in the value for cosine of pi over 4 and sine of pi over 4. Next, from the position of angle pi over 4, we increase the angle alpha until it reaches pi over 3. And remember the rule as alpha increases. The value of cosine will decrease to the square root of 1 divided by 2. The value of sine will increase to the square root of 3 divided by 2. Continuing to increase alpha until it reaches pi over 2. The value of cosine will decrease to the square root of 0 divided by 2. The value of sine will increase to the square root of 4 divided by 2. Next, from the position of angle pi over 4, we decrease alpha until it reaches pi over 6. And remember the rule as alpha decreases. The value of cosine will increase to the square root of 3 divided by 2. The value of sine will decrease to the square root of 1 divided by 2. Finally, as alpha decreases to 0 radian, the value of cosine will increase to the square root of 4 divided by 2. And the value of sine will decrease to the square root of 0 divided by 2. Thus, we have the table of sine and cosine values for typical angles in the first quadrant. Now, let's transform these values. The value of cotangent is obtained by dividing cosine by sine. Note that cotangent is undefined at 0 angle, as sine of 0 is 0. The value of tangent is obtained by dividing sine by cosine. Tangent is undefined at angle pi over 2, as cosine of pi over 2 is 0. Through this lesson, we have grasped the trigonometric values of characteristic angles in the first quadrant. In the next video, we will discuss the trigonometric values in the remaining quadrants.